Greetings, Hacksters! Welcome to another Hackster Cafe, where we talk to someone who's doing really cool stuff with hardware. And I'm especially interested and excited about this one because Sander is a maker at night, an engineer by day. But you create these really cool things that I'm so excited to talk about. And we've got one. You sent me one in the mail, and I'm going to unbox it. And we're going to chat about all the stuff that you do. So first,
Okay, cool.
good morning.
Yeah,
How's it going?
good, good. Thank you for having me.
And welcome, everybody. How's your day going?
Pretty good. Yeah, it's a nice
Cool.
day today in California.
So, what is it that you do? Can you tell our audience real quick?
Now,
I know
during the
that's a
day,
hard question.
during the day I'm an engineer. I work with hydraulics, and I'm a mechanical engineer by trade. But I like to work with software, electronics, for the last couple of years, and that evolved in what I do today. I'm able to apply it at my day job, but also at night I'm doing all this, new stuff, new creations, be really creative, and yeah.
Yeah, what all do you do at California Steam?
Yeah, so California's team started kind of in 2018. So my interest in the electronics started in 2016. I was always doing programming, but I never knew where to apply it. So I was doing websites and kind of things, but never really make anything that was valuable with it. Till I went to the Girl Scouts in 2016, and I thought scouts
Huh?
were always running around outdoors and just doing that kind of fun. But they were actually programming. They were young engineers. Really doing techie stuff, and I was really surprised. They're really actually teaching me how to hook up an Arduino, how to hook up an LED, how to program a NeoPixel. I didn't even know what a NeoPixel was at that time. So I decided to get one of those Arduinos, start programming it at home, did a little art project, like a little spider for Halloween that was going up and down.
Ah,
Was really, and it was funny too, because I couldn't figure out how to run the servo and the LEDs at the same time, because you had all those timers running in the background, and back then it was just all complicated.
hmm.
So I was studying it for about a year, and then decided to do. I was just doing little projects on the breadboard, and then decided to actually make a wearable. So my first wearable was for a run in October for the. And since it was in October, I want to do something for breast cancer awareness. So I made
Ah,
this ribbon.
that's so cool.
Yeah. So has this big, well, I'll call it big now. Back then it was small. I thought it was small. Let's see if it'll focus. If you can actually see it. If I hold it up here. There's a lily pad in the back here. And
Yeah.
each LED is wired to the lily pad. I was not doing any Charlie plexing or something like that, because I didn't even know what that was. And I found some code that
Wow.
allowed it to, the pulse is actually bit banging the pins. That's how you get these effects. Also,
Wow.
since it had like 20 LEDs, I was like, oh, I need like a big power supply, right? Because if I run 20 LEDs at 20 milliamps and
Uh-huh.
I want to run it for 3 hours, I probably need like 1200 milliamp hours. So I got this big battery pack in the back here, which is, looking at it today, since I know more, it's way of an overkill. But this will run for a month. Yeah.
Wow, yeah. And you say you use it for running?
It was, on the back of our shirts for a run at night.
Ah, cool.
Yeah. And then the
So if
next
you
one, since, yeah, go ahead.
please keep going.
Yeah, so the next one, I was like, well, this is quite a lot of work. Was it all those? I'm not sure if you can see them, all those wires in the back here.
Yeah.
They
I can't
kept
believe you wired
breaking,
those
and
individually. That's amazing.
yeah, and that was just so much work. So then I figured out you can actually get LED strips, the NeoPixels, and just run a strip in there. You're done. So I got a strip of those LEDs, and then our grandson said he didn't want a ribbon, he wanted the star. So I put them
Ah,
all together here. This one had the DigiSpark board in there.
I love those. Those are the
There it goes. Yeah.
AT Tiny
Yeah.
85 based ones, right?
Yeah, the 85. Yeah.
Those are so cool. That's gorgeous.
So that looked really cool, but this still took me 2 weeks to make, because if you can see in the back here, still tons of wires.
Uh-huh.
So my wife was like, "Why don't you just teach this with the kids, right? How to make more of these, because the effect is so cool, and then they can use the sewing machine and do something creative." And we're thinking about teaching it at the libraries. But the
Oh
problem
yeah.
was that I was burning my fingers. It took me 2 weeks to make one, keep breaking. So like, well, I don't really want to do that with kids because I
Mm.
don't want them to get hurt. So I was already doing stuff in KiCad, and I decided to make my own board. I got actually a grant from the Stockton Arts Commission to do some work, and that allowed me to make a bunch of little boards.
Ooh.
So I got these. Let's see if I will focus. There we go. So I made these boards with a grant from the Stockton Arts Commission, and I was teaching at the library, so the library is on there too. And I'm gonna turn this on. So you can just slide these arms
Wow.
in there, and then it lights up. It doesn't look that bright right now because it doesn't have a diffuser on it.
Super cool.
So took it to the libraries. They have their maker space with sewing machines. And we were teaching the class, and it took about 4 hours to complete one, and we were scheduling it for only 2 hours. So it was first class way longer than expected.
Oh yeah.
Um, but
Well, especially when you're
oh
teaching, like, soldering. I've taught a couple of bike lights workshops to people,
yeah,
and there's so much, obviously with those actually we had to do a bunch of, like, stripping and, like, measuring and all that good stuff too, but, like, still, like, when you have to work in teaching a bunch of people to solder, it always takes longer than you expect, so I don't know.
yeah. Luckily, this one you didn't need to solder because everything was on the board itself.
That's so cool!
So you just slide in the arms, you were done. It's just the sewing machines were acting up, and it was just
Oh,
a
no.
disaster. Uh, but that's kind of how California's team started because we needed a business name to receive the grant from the Stockton Arts Commission, and we're like, well, how do we call ourselves? What do we? Because we do art, we do technology, a little bit of
Mhm.
science, I do engineering. So we decided to go with which team, add the art to STEM, and that's how California's team started basically.
Yeah, that plug and play design is awesome. And you mentioned that you made these in KiCad, which is you published a tutorial on Hackster on how to create phototactics patterns, which is that the golden ratio or the Fibonacci spiral?
Correct. Yeah, yeah. So I thought it was good to share with everybody because it's kind of tricky to create a plugin, and it's this is just showing an example of how to make one in KiCad 8, and you can just modify it to your own needs. But yeah,
This is
this is
so
really
cool.
helpful. Yeah.
I love KiCad. I've never done scripting with it because I'm kind of terrified of software, funnily enough. I'm getting there though. I'm trying to challenge myself some more this year and get deeper into it. But like, this is so cool. So if
hmm
anyone else is in the same position, yeah. So you started out with KiCad. Have you ever tried any other PCB design CAD software?
No, no, always KiCad. So I cannot compare it to any other software package because I only know KiCad.
Well, it is a very good one, and of course, open source.
Mm.
Um, Speaking of comparing things though, I'm very interested because okay, well actually let's take a look at this thing that you sent me because I'm very excited about it. Okay, so
hmm
on your website, okay, quick preface. I heard about your work by running into someone called Jelly Squid. I forget her real name. I'm sorry, but
hmm
at the Visitacion Valley Lights Festival, I think it
Visitation.
was.
Yeah, yeah. And the funny
Yeah,
thing was,
yeah.
I was there too, and I saw you. Yeah.
Oh yeah. My brain. Anyway, I saw these things that she had, and I was like, "That is incredible." Not just that, like, they are LEDs, but also that you've done this really cool work with supercapacitors, which are something that I've been wanting
hmm
to learn about for ages. And could you tell us what the advantages are with using supercapacitors in your jewelry?
Yeah. So I started using supercapacitors because there's a ban on coin cell batteries unless you really secure them into your wearables. So I started looking for alternatives. I've been doing projects with supercapacitors since 2019, like the duck. Uh, Only problem was that supercapacitor is just massive. It doesn't really fit a wearable. It's just, yeah, here we go. This is like a 4 farad capacitor. I mean, it works great in this creature, in this sculpture,
So
but it
cute.
doesn't really fit a wearable. It's just too big. And then it doesn't have enough energy storage to actually run the lights for a long time.
Mm.
So when I was when I was going to change, because it was kind of pushed by Etsy to remove anything with cone cell batteries. So
That
that
makes
kind
sense.
of pushed me to actually look for alternatives. And I was looking on DigiKey and I found these new, they called hybrid capacitors with, well, they were, at least they were smaller, but also they had more capacity. The only disadvantage was you had to charge them at a certain current. You cannot just plug them
Mm.
into any USB port and just give it a full blast like I usually did with the other capacitors.
Yeah.
But you also had to limit the under voltage, so you cannot drain them more than 2.5 volts.
Huh.
So there were kind of disadvantages, but the advantages were that you can actually charge them in only a couple minutes, and they don't explode. Because a lot of people, when they hear the supercapacitor, they're like, "Oh man, if that thing shorts, it will explode." Or when you overcharge it, well, they
Uh-huh.
don't. They have a little, and I can show that here.
Oh,
Uh, yeah,
yeah.
see if it will focus. Right here on the end, you will see there's a little cross there.
Uh-huh.
That's really like a little vent. It doesn't want to focus right now. Here it is. This is actually one that actually opened. This one cracked open because I was shortening the ends. They were touching each other. So when they get hot or when you put too much current in there or too much voltage, they just crack open at the end and they just gas out. So there's no explosion, no danger
Mm.
there. They don't catch fire. I've seen videos online where people actually run nails through them to see if they
Wow.
explode. They just gas out. I know from experience when you run a nail through your LiPo battery, it does more than just uh, venting out. It actually catches fire and you're in
Yeah.
danger. So that's a big advantage. Yeah, the charging, the safety. So there are no shipping restrictions. And then you can recharge them up to 500,000 cycles. So if
Wow.
you recharge them once a day, they'll probably last for the next 2,000 years.
Dang. Yeah.
Yeah.
No.
Someone said, well, your USB-C is obsolete by then, but
I was thinking about that because these are so much better than for me. It's such a frustrating thing around creating PCB LED jewelry is that I go through so many coin cells and I'm like, oh, this is so wasteful. Not only that, but like I've created this jewel thief circuit so that I can use because often if you're at an
Mhm.
event and your LEDs even just get like a bunch dimmer, then it won't look like it won't really show up. And so even before the battery is dead, you kind of got to swap it out to use it properly.
Mm.
And so the Jewel Thief allows me to like suck the last of the juice out of those ones and not let it go to waste. But still, you're piling up all these dead batteries. You got to figure out which ones are still good and which ones are dead and which ones are halfway. And it's just
Yeah.
like so being able to use something like the supercapacitors and then getting so many cycles that you're not basically the yeah, the tech will go obsolete, like you said, before the supercap wears out. That is so cool.
Yeah, and then
Love it.
also when I designed the wearables or when I started off with like the small ones, like I think this is the original. This was my first.
Ooh,
That was my first design, my first earring that I designed for a festival. Same thing
gorgeous.
there. I didn't know what I was doing, first of all. So I was like, if I use white LEDs, the forward voltage is only going to be 3 volts. So I can use a cone cell battery without damaging the, the LEDs, right? That was my thinking.
Mm,
Today, I know actually the cone cell battery itself doesn't have enough current to actually do any damage. So you don't need any uh, resistors on there at all.
mm.
But and I was like, well, this cone cell battery is like 52 milliamp hour. And when I was running it, I mean, this is the mode it's running in. I was actually able to run
Oh,
this
there we go.
for a couple of weeks. And I'm like, well, I didn't expect it to last that long. And the same thing happened when I started designing the Fibonacci earrings, the original ones with the batteries. I was like, well, there are 104 LEDs on there. If I want to power all of those, I need probably around 50 or 60 milliamp hours. And if I want to run those for like 10 hours straight, I need like 500 milliamp hours to power them all, right? So on those original ones, I used the Sync Air batteries. And after I designed it and built it, they were lasting for 30 days. So I was always off. I did my calculations on how much energy they were using. Till I got one of these power profiler kits
Oh
from
yeah.
NRF. And then I was able to figure out how much they actually use. So the Fibonacci earrings, when they're running, they are about a little slightly over 1 milliamps. And that allowed me to go to smaller supercapacitors, because the supercapacitor is not able to bring out to deliver like hundreds of milliamp hours. It's only limited to like 10 or 50 milliamp hours. But since my power consumption is so low, around 1 milliamp, I was able to still run for 15 hours straight.
That's so cool. And I want to bring up this power profiler kit that you were talking about. This is a
Yeah.
Nordic product that we've covered on the channel before. Check it out. Yeah, you can use it with a ton of different things.
Oh yeah, it was really an eye opener. Yeah, and it's nice too because you can actually set your voltages. So you can like the supercapacitor is going to drop in voltage over time. It starts at 3.8 volts and it then drops down to 2.5 volts. So I can actually hook it up to the power profiler kit, change the voltage, and see how the LEDs are changing. Because what you said, if the voltage gets lower, it's less bright, so you have to compensate for that. But another advantage is if you get to the lower voltages, that actually gets more efficient.
Cool. That is, this is mind-blowing. So I would love to take this thing out of the envelope now. As I mentioned before we got on here, I did open the envelope, but I haven't actually taken it out of here at all because I wanted to like make it be a moment. So this is a new one that you sent to me. There's the there are the round ones, and as I understand it, this is one of the little heart guys.
Yeah, this is a little bit different.
It's got a note. I love it when there's a note. Instructions can be found under the lid. Perfect. Cool. Oh, there they are. But first, well, not first now. Let's pull it out. Okay. So you had a little piece of foam that I have dropped because chaos. But check it out. This is gorgeous. It's on this like little velvety base here. And I'm going to take it out. And it just has this little slot that it sits in. And there's the supercapacitor. So cool. Yeah. I'm really curious about this retention system that you have in here. Is that a piece of insulated wire? It is.
And no, it is actually the silicone over some copper wire.
Oh, okay.
Yeah, to hold it in place. Yeah.
And you've got two PCBs on here. I was under the impression it was. That makes total sense though, because you're doing some.
Yeah, I don't want to show any through holes in the front. So when I do my PCBs, I always have one that's this one. So this is the I call the charging circuit. That holds the supercapacitor. Then I will attach it to the actual board.
This is so
all
cool.
the LEDs. The way it doesn't show any through holes in the front.
I like the silver outline on it as well. It's very shiny. You got all the kinds of shiny on here. You gotta have like the silvery shiny and the like LED glow. So you told me that I should have a USB-C cable for this. So I've got one here, and I should have plugged it into my computer before, but I didn't. So I'm gonna do it now.
Because when I ship these, I kind of lock the push button, and you can unlock it with the USB cable.
Aha! Right. Here we go. Moment of truth, and I'm gonna get my headphones out of there. And a light has turned on the back, a red light showing presumably charging. And so now the button is unlocked. I'm gonna push it.
Yeah. There it goes.
There we go. Gorgeous. I'm gonna try not to shriek too much, but this is really pretty. And so what happens if I push the button again? Do we get a different pattern?
So you have different modes. So this is like a random mode. And I really like the third mode. It's I call it the party mode. So so it changes patterns every.
Whoa.
Yeah, so every half a second it will pick a new pattern, and it repeats. Every 4 patterns are repeated for 2 seconds.
Cool.
And then it updates the patterns again, and then this does it at 140 beats per minute.
Oh.
So if you go to a rave,
Super good. I've managed to get pen ink all over myself already, but
yeah, this is the theater mode. So if you go to the movies, you don't want to.
Brilliant.
Yeah.
I've one thing that Sophie Wong has talked about in the past is like turning off her LED jacket when she goes into talks and stuff, so she's not distracting people from whoever's speaking. And that's another like application I could see for this. Like you want to keep your little sparkles on, but like not be a
Yeah,
jerk
yeah,
about it.
yeah, exactly. Yeah. And then the
Or
last
like,
mode is actually the minimal mode. So in this mode,
mm,
if you hold the push button for like 3 or 4 seconds, you will see it will move to the next spiral. There it goes. Let go.
oh,
Oh, now turn off.
whoop,
If you hold a
a
little
little
bit
too
too long,
long.
it will turn off. But if you do it again for like, yeah, and now you click. Yeah, there you go. So now you can actually, if you keep clicking the button, it will change the, I'm not sure which mode you're in right now, but
Yeah, I'm gonna try and like figure out my shading situation here.
yeah, yeah.
So I can do both at once. I'm gonna use this hand to click the button and that one to shade. And turn it off again, did I?
No, you change. Well, I think you're in a mode already that shows all the LEDs.
That's cool.
But yeah, in the manual mode, you can actually pick the spiral you like to see, like
Oh, I
the,
see what
because
you
it's,
mean. The like
yeah,
little LED in the center changes to show
yeah.
what mode you're in. Maybe I could be lying about that.
So
Anyway,
yeah,
I'm
now
gonna have a
you're,
lot of fun like messing around with this and learning all the different modes. Oh yeah, you've got all the instructions here, so you can scan the QR
oh yeah, you
code for
scan
the
it and then it'll bring
instructions.
it to some videos. Yeah.
In case you're like me and immediately lose this kind of stuff, store in the box when not in use, fully charged before storing for an extended time, keep it away from conductive materials and liquids, and make sure that party mode is selected before you hit the dance floor. Uh, it strikes me as well that like I actually really like this strobe mode. It strikes me as well that like the dim mode would be good for sometimes. I love to go stargaze, and sometimes there are like telescope nights and stuff, and you don't want to get
Oh,
like
that will hate
glaring light at
it.
people. Yeah, got to keep your night vision, so that's good for that too. Or stealth parties, get a stealth party in the redwoods. Not that I anyway. So Alloy Innovator asks, how long will the supercapacitor hold the charge without use?
So it actually goes into a sleep mode where it only the power consumption is about 100 nanoamps. So if you fully charge it and then you leave it in the box, should last over an hour, over a year at least.
Wow.
Yeah.
And now that I've got it unplugged, I when I unplugged it, it turned off again, but now I can hit the little button
Yeah,
and
it
it
goes to
comes back
sleep mode if you
on.
unplug it. Yeah.
Very cool. And I'm gonna try not to fidget with this the entire time, but this is so cool too. Okay.
So
Back to
this
the question.
supercapacitor was kind of interesting too because I've been using the 3.8 volt supercapacitors, and
Uh-huh.
I'm actually working on some projects right now when I want to use RGBs,
Uh-huh.
but I want to have a little bit more capacity from the supercapacitor. So I asked my vendor to yeah, go, because this is a 40 farad, or actually this is 90, but originally I used 40,
Mm-hmm.
and I wanted to go to 70, and then they told me they have a 90 farad supercapacitor that's only 5 millimeters longer, and that's this purple one.
Ah.
And then they sent me a picture, and I'm like, oh, this is 4.2 volts. It makes it so much easier to charge because now I can use a regular LiPo charger to charge these, and those are
Yeah.
widely available. On the original Fibonacci earrings, I created my own charging circuit.
Mm-hmm.
So it has like I said, a diode to limit it to like 3.8 volts, so it doesn't never overcharged. And the MCU itself is also checking the voltage all the time and is able to turn off the charging circuit if needed. So there's some redundancy built in. But going to 4.2 volts makes it so much easier because there's so much out there that already runs in 4.2 volts that you can just use existing ICs and just use those on the board instead.
Sweet. Let's take a look at some more of your designs. So you've got this one that we looked at with the heart, which I believe the round one was before then, and also I think these ones are just so gorgeous and sci-fi looking. I don't know if you know about diesel punk, but for some reason these give me that kind of a vibe. I didn't apparently pull those up before, but
Yeah, and the reason I did that, because the original earrings, right, the first ones I did with this microcontroller, I wanted
mhm.
to show the microcontroller because that's what's running the LEDs. So when I was going to the supercapacitors, I wanted to show the supercapacitor to the front.
Yeah,
Because I'm like, this is actually what runs it. This is what's special about these earrings.
it's so cool. And I think that's what caught my eye initially. I was like, "What's going on there?" I love how it's just, like, stuck through the board. Is it actually stuck through the board, or is it no, it's just yeah, it is.
Yeah.
That's so
Hmm.
cool.
Yeah.
Ugh, big fan of, like, weirdly shaped PCBs, and you showed the charging circuit one before, which has its own cool shape. I know it's on the back of the board and it's underneath the supercapacitor, but it's still cool looking. Anyway, I
Hmm.
adore these. This is so cool. And you've got these, are these older or are these,
These
just
are pretty new. I
semi-new?
finished
Oh,
those a couple months ago.
and I
So,
noticed that you've got yeah, you've got some stuff soldered on top of the
oh
PCB
yeah,
and some resin applied as well. Do they come with that, or is that like a part of
no,
the
I all yeah do those by hand. Like actually, so the only thing I'm able to see,
cool.
here they are. So this is how they are. I just had to grind off the edges and then I had to start soldering everything by hand. It's a good focus, yeah. So the like the flame is reverse mounted LEDs. Um, the little window is a through
Cool.
hole LED. So nothing can
Very
be done with the pick and place, only the ones in the front. So you can
uh-huh.
see it has the microcontroller already attached and the circuit here.
I like that you're using multiple ways of applying LEDs. So you've got the like you mentioned, the shine through ones that are reverse mounted on the flame, and then
Hmm.
the through hole one again, like poking through the board. Are there any that are regularly mounted as well? Oh yeah, I see the charging one on
One,
the back here.
yeah, the one on the front, yeah, and the top is for charging, yeah. And the
Cool. Oh,
charging
it's
is
on the charging.
also it's limiting the current or um, so without that LED, the charging circuit doesn't really work. So it's
Oh
really
wow.
important to have it, yeah.
It's a very
And then
minimalist
I
mindset. It's all
yeah,
functional.
and then I put epoxy over it too to protect
Mhm.
it because I don't want the earring hook to land on there and then short one of the 4.2-volt circuit and
Yeah.
start to spark. Yeah.
I've gotta start doing that with some of my, PCB LEDs or LED PCBs as well because, that and I tend to, like, not store them well. I'm absolutely gonna keep this one in its box. I've actually already got it back in there so that I don't forget, like it says on the instructions to keep it safe, but, I have a bad habit of just sort of, like, tossing stuff in my bag in a little pocket where it goes, and, like, that's not the best practice, and, so controlling for that a
Yeah.
bit with this epoxy resin is smart.
Yeah. A lot of my earrings went through some testing in the last 2 weeks during Burning Man. So,
Oh, yeah. How did that
well,
go?
I wasn't there, but I got feedback from some customers. Most of them survived. Only one died, but he said it was his fault. So, I'm not
Legit.
sure what he did, but
Yeah, who even knows? So you've got all these different colors of these, I wanna point out, and there's also something, that I'd love to just ask you about, which is, I noticed that you have one of the ever-blooming flowers from Yuri Praus in the back,
oh
you can see.
yeah, that one is still
Yeah.
going. Yeah, it's
Interviewed him a long time ago, but, oh my goodness, such a long time ago, but yeah, tell us about this how did you end up with one of those?
well, I built one. Yeah, so
Cool.
it's yeah, it's just was a lot of work, and uh, I just like to show it at shows. It's
Yeah,
just the
what
problem is
attracted
that
you
the all those
hmm.
wires keep breaking. So now I'm
Oh,
used.
yeah.
Let me get it closer.
Sure.
Let's see if it'll focus. Oh yeah, it actually does. So I'm using silicone wires underneath there now, and it seems to hold it much better.
Cool.
Yeah.
So it was the, power wires that were breaking?
Oh
Like
yeah, yeah. To the pedals.
mm,
Yeah. Uh-huh.
legit.
And
Well,
then also
yours came out beautifully.
yeah, also everything I do it with the 80 tiny because I love the 80 tinies. So
Mhm.
I used the 0 and 1 series. So this one has like an 80 tiny 1616 in there to yeah, control the servo. Like I told you in the beginning when I did that spider, I didn't know how to do a servo and LEDs at the same time. Uh, well, this one does it all. So I learned how to do it now. Um, I also have a bunch of butterflies, also running off an 80 tiny 1616 where I have 2 servos and a bunch of LEDs to light them up and they move.
Ooh, and are you programming these? One of the things that I love about the AT Tiny series is that it is possible to program them with Arduino code, even though they are so tiny and can be so low power.
Yeah,
Although you are a professional software developer, and so I'm curious, like, do you run those on Arduino code or do you write something else?
yeah. So the flower here runs on Arduino code because it makes it easier to pull in libraries like the Adafruit NeoPixels. But all the earrings, they run directly from FML Studio or Microchip Studio today.
Oh,
Because it
cool.
allows me to tweak all the timers to the way I want it. Because I want to make it as efficient as possible. So really, when I'm programming this, I'm really counting the clock cycles. Like how long does the microcontroller stays on before I can put it back into sleep mode? Because sleep mode is really helping me to bring the power consumption down.
That is so cool. This stuff is such deep magic to me. We had Kwabena Ajaman on here a couple of years ago who was talking about like power optimization and speed optimization in the OpenMV cameras. And I wonder if there's, feel free to get nerdy with that, but is there anything like special and cool that you're doing in order to get the power down? You already mentioned the sleep mode and like
Yeah,
different
yeah.
methods.
So yeah, a lot of people think that if you go to lower frequency, your power consumption will go down, which is true if you leave the MCU running at all times. Um, but if you put it to sleep mode, it doesn't really matter how fast your MCU is running. Actually, it's better to have a higher frequency because you can
What?
go to fast mode earlier, to sleep mode earlier. So what I do, for example, on the Fibonacci earrings, I update all the 104 LEDs. Like in microseconds, and then I put it right away in sleep mode again. And then after 1 millisecond, I update them again. So the update rate, the frequency is about 1 hertz. But within that 1 hertz, or sorry, 1000 hertz, but within that 1 millisecond, they're only on for like a nanosecond. It's
Wow.
very short. Um, then on the RGBs, and actually it's kind of cool because I'm working on this new project. I'm going to call
Mm.
it the glow cap.
Cool.
See this one here.
Uh-huh.
So I'm running the RGBs here. So I'm running these from the actual PWM timers, but I only run it for one cycle, and then I turn off the MCU and the LEDs. And then there's another timer running that wakes up the MCU again, and then it's going to update the PWM outputs for just that one cycle, and it turns off again.
Wow.
And by doing so, it gets really efficient. They're not that bright, but usually you don't need brightness. You just need something that glows and people can see it.
Mhm. Yeah, often it's, like, way too bright when you first fire up some
Yeah.
NeoPixels, you gotta dial it down a bit. Can you
Mm-hmm.
share what your plans are for this GlowCap project?
So this is going to be, I have some artists that are interested in lining up their work, and this is a piece I made.
Yeah.
I mean, it's not that good, but yeah, you can just put it in your candles, or I have some people online that make wearables. They want to have an alternative for their cone shells, so they're going to add
Mhm,
these to their work. So it's not something really I'm going to use in my own work, but it's more for other artists to
mhm.
apply to their work. I mean, I'm not really good at ceramics,
It's
so this
beautiful.
doesn't look that great.
I mean, everything looks better when you light it up with some multicolored
Yeah,
LEDs,
yeah, exactly. Yeah.
But yeah, it's basically like a throwy but rechargeable and, like, way cooler and, like, runs for longer and can run more stuff on it. Ah, rad.
Yeah, because I was kind
Um
of worried because I only have this is a 90 farad supercapacitor, so I have like 50 milliamp hours. Uh, the the guy I'm working with, he had originally using, I think it was 100 milliamp hour lipo batteries, but he said these were brighter and still lasting as long. So I'm kind of happy with it. And I think it's
Nah.
mainly because of the coding. I think it's all how the MCU is going to sleep mode all the time, because a lot of energy is wasted by the MCU.
Absolutely. It I have all these LED tea lights that where they've chewed through a couple of coin cell batteries. My ex-housemate like had a ton of these for like an art installation that they had put in little like
Yeah, yeah,
bamboo thingies. And it's the same situation where I'm trying to convert them over to this jewel thief circuit so that I can power them off of like dead batteries and like chew through this pile of ones and like get rid of them and then like transfer everything into like rechargeables and stuff. But I still have this pile of like antiquated LED tea lights and I'm like uh just being able to upgrade them with something like this would be so cool.
yeah.
I know that
And
on the rocket ship you've got some flame effects, so you've already done that part.
yeah, exactly. So I want to update this too with some flame effects. Yeah. But
I
the
love it.
original goal was just to an RGB, a regular RGB. So I got that goal achieved already. But yeah, I
Mhm.
want to make it with a candle effect. So you can actually put it in a candle, but also have different colors. You have a purple candle instead of just yellow.
Mm.
Yeah.
Very Halloweeny. It is
Yeah.
coming up on
Uh-huh.
that season. Love
Yeah,
it.
better hurry up.
Your house has got to be the coolest when that stuff rolls around.
We have
Um,
butterflies flying around, a big sunflower in the front during Halloween. Yeah, it's decorated.
cool. Uh, so you've got another piece with some, again, you've done like shine through LEDs, you got LEDs poking through the boards. Here you've got some that are edge mounted. And are they just like not on and they look black, or are they pointing outwards, or
Oh
what
yeah,
do they do?
these were a disaster.
Oh
I
no!
don't think I don't think I put a description in this listing here. I put it on Tindy, and the Tindy explains the mess I made with this one. So
Oh,
the battery holders were backwards.
oh
So
no.
the instead of having the positive on the holder, the positive was on the center of the the holders. So yeah, so those didn't work at all. Um, they're really cool because I just hooked up some wires and I light them up and they're awesome. It didn't work with regular batteries. So then next I ordered them again because these are placed with pick and place the LEDs because I cannot do
Uh-huh.
that. So I ordered them again and then they placed the LEDs. They turn them 90 degrees when they place them on the boards. Now I still cannot use the RGBs. Uh, so the only thing I can do with the ones I'm offering on Tindy, uh, there are like these here.
Ooh,
Oh, come on. There it goes. So
cool.
I'm only able to control the green one, and then the blue and red I can only turn on and off all simultaneous.
Uh, it's a cool, like, rare variant.
Yeah, but the tree you see there are the actual traces going to the LEDs.
That's so cool. I love that. Using the traces as a functional part of the design is a favorite thing of mine to do as well. Like on the skeleton PCB I made. But I love. Okay, you do. For the record, he does mention that they have a glitch that does not allow them to work with the batteries. So you
Yeah,
know what you're
yeah.
getting on there. And nonetheless, you still all only have 9 left. So that's kind of cool. Like they're
Yeah,
rad
so
looking.
I still have to
Um,
make them. There's still some work involved, so I always make them in small batches. Yeah,
mm.
because I
And
put
as you see, those are functional traces. So
yeah,
cool. Um, I would love to ask you about, you've got links on your site to Etsy, to Tindy, and to Lectrons, which is one that I haven't heard of before, actually. I'm curious
yeah,
about your experiences with these.
yeah. So on Etsy, I'm only offering my supercapacitor powered variables. So there are
Hmm.
no battery operated here because they're not allowing those.
Right.
Um, but on Tinny, I'm offering everything. So Tinny has everything that's still original, like the skull LED earrings. Those are like
So cool.
6 years old now when I originally designed those. But those are with the 8010 84A.
Uh-huh. What
And then
is so the 84A, is that a lower power or lower memory? No, the 45 and 25 are like lower memory, right? And then
yeah, they're lower memory, but they're pretty old microcontrollers. So all my new work, I'm replacing with the 8010, like the 1616 or the 8010
uh-huh.
412, because they're newer. They were introduced, I would say, 6 years ago. They have more timers. They're really low in power consumption, and they're
Hmm.
widely available.
Very important. I remember there being some issues with at tinies during the start of the pandemic. AT
Oh
tiny, at
yeah.
tiny. I sort of
So I
swapped
have
between them.
I was piling up during the pandemic. Every time I could find some. That's why the automotive industry was short, because I was using them in my earrings.
Well, this is much more important.
Yeah. But Tindy is still, yeah, the place where I offer everything. But it is difficult to ship from Tindy to Europe because there are new shipping restrictions.
Oh.
That's why I'm using Electrons. Electrons actually collects the taxes before it ships to Europe. And it makes it so much easier to import it.
Oh, cool.
But I didn't list everything on Electrons yet. No, I still work on that.
But everyone, you can look in the description to this video to find links to all of these. Actually, I might not have put all of these on there yet, but absolutely after the episode, you'll be able to do that. So we are chiefly a documentation community. There's, our news blog and obviously videos and stuff, but the heart of it is tutorials. And I'd love to hear if you have any tips for people who are writing tutorials, especially since you've taught people in person as well and worked with young people and presumably possibly older people as well. How do you make it easier for people to understand and to go from like reading a tutorial or following your instructions to having a real life thing?
I think it's very important to have examples in there. That's how I learn when I read
Hmm.
tutorials. If it's just a lot of theory, it's for me really hard to follow in tutorial. But if it's something I can follow step by step, showing examples, actually apply it, it's for me easier to learn as well. So when I write tutorials, I actually put in there an example, put in the code, so people can follow it and understand. And I kind of broke it down in different steps too. I didn't just threw the entire code in there. I kind of explained what does the first section do, what does the second section do, and have it grow slowly.
So cool. Lots of comments in here. I might have to follow this one because I've never, like I mentioned, like I've never done much that's more intense than just like GUI stuff in KiCad, and I'm a little hesitant around like intimidating code still.
I was
Still,
like, and for me, it's easy too, because I can actually, if I forget how I did it, I can go back now. I'm
yeah.
like, oh, that's how I did it. Yeah.
That's how I got started in this whole situation where I ended up like being like community manager at Hackster like 10 years ago, was because before that even I was creating my first like maker blog, was mainly just like writing down stuff and taking pictures so that like I would remember what I had learned and I'd be able
Yeah,
to do it
yeah.
again later. And so it's totally valid, like writing it for yourself. And I think that's part of like why it's so cool and important to always have new people coming in. They don't know everything, and that's awesome because that means that they're like creating more documentation and stuff at the start of the journey, so that other people who want to pick it up for the first time, even there if there's a billion tutorials out there already for something, sometimes it takes a specific one to like
Mm-hmm.
click with your brain. And if someone like us who has more experience with one side of it or another, we may not like think to put in all the basics. We're like, oh, everybody knows that. Obviously, there's like an XKCD cartoon about that, and it's like, no, everyone doesn't know that already. Like how to use heat shrink.
Mm-hmm.
How to solder even. But then other stuff around like don't put it in a conductive container and stuff like that. It's like that's important.
Yeah, when I started, for example, with the 80 Tiny 1616, the one series, there was not a
Mm-hmm.
lot of documentation out there. So I was kind of learning while I was going. And I was writing tutorials just for me, was forcing me to understand what I was doing.
Mm.
Because if you want to teach someone, you have to understand what you're doing. Um,
You say you were writing
the,
tutorials about how to use the AT-Tiny 1616?
yeah, they're on Hackaday.
Cool. I'm gonna go check those out.
Yeah.
Absolutely. I want to learn about that.
Every
Yeah, the
step I was taking, I was like, kind of writing there what I was doing. And that's how I also started, this little duck. I mean, I
Oh,
have
is
one
it their
here.
like
I think,
sculpture contest?
yeah.
I've got the
This is one of the
calendar from
first 80
that.
tinies. Yeah.
That's
Oh,
so
you have it on the
cool.
calendar? Yeah.
Yeah, I think it was like a giveaway at some event I went to, maybe Open
Yeah,
Hardware
on the
Summit or
Dipsy
something.
calendar. Yeah. That's
Yeah.
funny. Yeah.
Check out all these gorgeous things you've got on your Instagram. Everyone go check this out. There's like I'm such a sucker for macro photography of electronics. Oh, it logged me out when I restarted. Okay. Anyway, though, I love being able to see this sunflower that you were talking about a minute ago. So
Yeah,
that,
right
and
now
then
it's in a classroom. Yeah, right now, in the art room.
awesome.
Yeah,
You mentioned butterflies flying around as well
yeah. If you well, you have
on your lawn.
to. So if you go up back to that butterfly, or sorry, to the sunflower, it's
Hmm.
in that same video. But I'm not sure if you can open the videos without logging in first. Yeah.
I'm going to see if I can
Oh,
swap
if
to
you go
you
to
for a
my
sec.
if you go to
Maybe.
my California Steam website, it will show on there too.
Cool. Let's do that. And I think we just
And if
implemented
you, yeah,
actual
there you go.
offline.
So the installation art, you can see them.
Aha! I think I wasn't able to click on this before,
No,
but
there's
in the
nothing
portfolio maybe.
finished yet, but at least it shows you
Oh!
the butterflies. Or are they also on YouTube? Yeah.
Oh yeah! There we go. Oh, of course!
You've
These
seen
are
those.
these are
Yeah.
the ones that I saw at the light festival.
Yeah.
Super cool. I want to check out your YouTube. I'm gonna look that up, and I'll drop it in the links in the description as well. Unless you don't want to share it for some reason. Sometimes people are like, "Oh, there's old stuff," but let's see.
That's all fine.
I'm gonna pull it up. California Steam.
Yeah.
Awesome.
Oh, so YouTube, I think it's using my initials, SVDVOR.
Cool.
Let's see if I can.
Well, we'll find it and stick it
Yeah,
in the
I will
thing, and
send
then
it to
everyone
you.
can look
Yeah.
at the pretty butterflies.
Yeah.
Let's see. So we're coming up to close near the end, and I would love to ask you some questions about you and your journey.
Okay.
So,
Yeah.
how did you get started in electronics? You mentioned that you were a Mechie first, and then in 2016 you started getting into Arduino.
Yeah.
What was the journey like before that? Like becoming a mechanical engineer? How did you decide to go into that? And yeah, what was that whole
When I was
situation?
young, I was really good at numbers. I was horrible at language. Uh, I just hated like German and English. I look what
Yeah.
I'm here today. Uh, so we didn't have a computer at home, so I didn't know I would like programming or anything like that. But I knew I wanted to do something like an engineering degree. So I started doing mechanical engineering. And I think if you want to go doing engineering, you're not sure what to do, I would go for mechanical because you're going to learn all the different trades. In school, we learned programming too. It was part of it. We even did some digital fundamentals where we learned how to write something in assembly. It was something that is probably not taught today, but we learned that back then. We had no clue what we're doing, but they were teaching that kind of things. And then, yeah, after I had my degree and I started working, I understood that I actually like programming too. So I was interested in doing some PLCs. I did websites for a while. Actually, I was designing websites for companies in my free time.
Cool.
But
And
it
you've
really
been.
took off.
Oh
Yeah.
yeah, sorry, go on.
Yeah, but it really took off when I started to learn how to use microcontrollers. So this is
Mm,
something I can really make it look pretty, but everything that's done in that microcontroller, that's the key.
mhm.
I usually don't like to do the front end.
But your PCBs coming so gorgeous.
I know people say that. Yeah, thank you. Yeah.
And you've been at your current position for 17 years at Hager Inc. So
Correct. Yeah.
a lot of the wisdom that I hear thrown around is that like, so I've been at Hackster for 10 years, and I'm always hearing these things of like, you should be changing jobs every 2 years in order to maximize this and that and whatever. And I'm like, but I'm happy here. I like what I do. And I'm curious, like, what is it that has kept you in the same place for 17 years since
Because
it's not
I
as
was
easy
able
these days?
to keep changing. Yeah. For example, I started as a mechanical engineer doing their tooling design.
Mm-hmm.
And then during the recession, I took over an entire engineering department. And then after the
Wow.
recession, we had to make some changes to the machine because of safety, and we decided to go to PCBs. So I was really doing kind of PCBs at work too, but that was not
Hmm.
job. I had someone working for me till he left, and then I had to take over. So that's how I kind of rolled into that role too. It was not just the Girl Scouts, but it was about the
Mhm.
same time. The Girl Scouts kind of pushed me to actually start getting an Arduino and actually start learning it, so I can actually take over that role of that person that I lost back in those days.
Mm.
But it allowed me to actually expand my vision, and I'm the principal engineer today because I know the hydraulics, the mechanical side, the electronics, the programming, and some stuff that I cannot fix through hardware, I can actually fix through software now because I know what's
Nice.
possible, and it is. I think it's helpful. It's before we had the department separated, and there was always kind of a conflict. Like you have to fix it through hardware, but like, oh, it's such an easy software change that I don't want to do it. Now it's all one department, and I can kind of oversee it and make decisions there.
So
And
cool.
that kind of kept me there because I was able to keep growing and try new things. And we're still working on new stuff today that's kind of unique and it's not done before.
Yeah, I feel the same way, honestly. I love what you say on your LinkedIn profile that my knowledge of the machine is unique. And also, I just love that phrase for one thing. And then also, you mentioned that you designed the upper tool change mechanism on the machine yourself, which is super cool.
Yeah, that was my first project when I came to the US. Yeah.
Ah, cool. So
Yeah,
you mentioned that. So are you from Holland or Sweden?
yeah, Netherlands. Yeah, from
The
Holland.
Netherlands, right? Yes.
Yeah.
So you mentioned though that you were learning German as well. Is that just something that was a requirement in school, or?
Also, a requirement in school to learn German. I hated it, and then I decided to study 1 year in Germany. So I had to learn how to speak it properly. Well, I mean,
How
probably
was
never
that?
did it properly, but we were able
Ah,
to communicate with other people there. Yeah. But I think it's kind of cool. If you go to the country, you will pick up the language much quicker, much easier. Um,
mm. I'm gonna avoid. I'm a language nerd myself, and I know that I'm gonna avoid forcing you to talk about that a bunch. 'Cause I know you get it. But let's go back through really quick, just a quick review of what we talked about. So we're coming to the end here, but I'm very excited to have gotten the chance to speak with you. Ah! So again, you can go to californiasteam.tech to check out all the different web shops. Again, there's some stuff on Etsy, but that's just the supercapacitor stuff. Then there's
mhm.
Tindy, and then if you're coming from Europe, you may want to use the Electrons shop, with more cool stuff, but also everything may not be on there yet. We've got a couple of previous Hackster articles about the cool stuff that you've done. Ah, the aesthetic on these is just immaculate. I gotta stop. And then, of course, your adorable circuit sculpture. Huge fan of circuit sculptures, dead bug soldering, that kind of thing. Yeah, what's your philosophy with circuit sculptures? How would you describe them and their
uh,
traction for you?
for me, it's because it's functional. It's
Mm-hmm.
still, I mean, on the duck, not everything is on there functional. Like the resistors are not doing anything, but I think it's just cool that you make something and it's actually uh, it has a purpose. The components are not just on there for looks; they're actually doing something. And the same with like the glow rocket. The components on there on the front, they're all there doing something. It's part of the charging system. It's um, yeah, it's all functional.
Yeah, I have the same attraction to it. I think that there's something so elegant about the fact that each part is doing something. And we also talked about the circuit flowers, which people can
Yeah,
check out the Nordic Power Profiler Kit 2, the AT-Tiny 1616, and you mentioned another one as well. I think it was the 412.
yeah, the
Uh,
412, or even if you want to go really basic, the AT-Tiny 202. That's what I use on the glow stick. Is the 202.
ah.
Yeah.
And when you're prototyping, I actually had a quick question. Are you using a dev board like this, or do you have your own board that you're testing with? Or
Yeah. So shoot, they have some here. Um, well, I can show you. I have when it's kind of a funny story because the AT-Tiny 1616, when it came out, I wanted to use it in Arduino, but there was nothing out there yet. Because it was not supported yet. We have spent a lot of time creating the AT Tiny core for the 84 and the 85 series.
Mm.
And a lot of people were writing in the comments like, "Can you make it for the 80 tiny 1616?" And he's like, "Well, it's a totally different tool chain, right?" And he's like, "I'm not even
Ah.
going to start it because there's nothing in Arduino yet." And I was like, "Well, I want it because if I can run it on the 80 tiny 1616, I can run the servos, the LEDs, all simultaneous because it has more timers than the 84A." Um, Around that time, Arduino came out with a Wi-Fi board at Mega 4809. This was using the same tool chain as the 80 tiny 1616. So I contacted someone at Arduino and said, "Can we just add the 80 tiny series to the tool chain then? Because
Mm.
then we can start developing a core for that." And they were willing to do that. Then I made a little board, and I only have half a board here because I cut it
Uh-huh.
off for this design. Let's see. There it goes. So
Oh, that's
so
gorgeous.
I cut out, this was the original board. It was just a VQFN footprint, 3 by 3 millimeters, to like a board that you can just click, put on your breadboard. Made a bunch of those. Sent one to Spence. I said, "Hey, Spence, I think we,
Mhm.
here you go." Because he's like, "Well, there's nothing for the breadboard. So now here's something for the breadboard. You can start programming it." Toolchain is there. And I was able to actually do some basic programming in Arduino and actually have the pins go on and off. So I knew the toolchain was working, but that's all the knowledge I had. I gave it to Spence, and he took off with it. If you want to program the 80 tiny 1616, go to his GitHub account, and it's a great core. But yeah,
Now
this was
that
a little, and then I did an 80 tiny 202, which is well, they're a little bit bigger.
Uh-huh.
Let's see if we'll focus right now. I just soldered some leads to the end, so I was able to push it into a breadboard. And then Carrie from Alpenglow, she felt sorry for me. Actually, she sent me
Oh,
some
yeah.
boards, so I got some official boards now for the 80 tiny I can use moving forward. Because yeah, it's just like, why are you making it so complicated on yourself?
Yeah, Carrie is awesome, everyone. If you aren't familiar, we've covered
Yeah,
Alpenglow
there
in the
she is.
past,
Yeah, yeah,
interviewed
yeah.
Carrie. Super cool. Okay, that bee circuit sculpture that you just showed, that is gorgeous. I
Oh,
was
that one.
like freaked out when I
Yeah,
saw that. Do you have
nice to
anything
check.
else like lying around that
Oh,
like we
here,
haven't?
yeah. Let me
Oh,
turn it on. Yeah.
that's so beautiful.
Let me see. Right there it goes.
Ah, again, I'm really doing my best not to like screech loudly. That's gore. I love the animation on those LEDs too.
Yeah,
It's so like a firefly. Is that what it is? Not a bee?
it's like I think it's a bee.
Mm. But the animation definitely also reminds me of fireflies, which are like living in California, coming from the Midwest, that is like one of the few things where I'm like, oh, I try to go
Yeah,
back in June sometimes
and then
to
I have
just for that.
this one here. Let's see if we'll.
Woo!
I think I'll put my hand behind it and we'll focus.
Oh, pretty.
And this one I have instructions for on my Hackaday as well.
I have to go pull up your profile on there because that's
Let's see. So there it goes. It doesn't want to focus. There it goes.
cool.
Oh, and I think this one is always cool to show at festivals. Oh, this is 8010 84A. You know the DigiSpark board?
Yeah, yeah, yeah.
Yeah, so the DigiSpark is an 85. So you only have like, I think 6 pins. This is the same thing, a DigiSpark. My design, the 80 is from California Steam. I'm sure you can see it. But based on the 84A, so you actually have up to 12 pins.
Cool.
And then if I plug this in, power cord here.
I just want to make sure that you're good on time. We are past 11:30 now, and I'm very happy to keep looking at these just to make sure we respect you.
Oh, very good. Yeah. So this,
Beautiful.
so it boots up right now. It takes like 8 seconds because the
Ah.
DigiSpark has the USB built-in. And there it
There we
goes.
go.
This always gets a lot of attention at the shows.
I've been thinking about designing more like bike wearables, like you're doing with
Oh
your
yeah,
walking ones. Actually, oh man, I didn't even get to. I want to ask you more someday about your soft enclosures for your electronics, like the first few that you were showing. And I didn't quite get there today, but hopefully we'll get to chat about that someday in the future, because you're mentioning these sewing machines, and I'm interested about the design considerations there. But yeah, there was one more thing. Oh yeah, so the question, you already are working sort of at the forefront of supercapacitor technology in this community. I haven't seen a lot of people embracing those yet. A little bit with some, like, I forget what their name is, but they were doing like solar powered stuff with little
Yeah.
tiny solar cells and supercapacitors, which I thought was cool. But yeah, you're already working with a bunch of really cool, like, boundary pushing technology. But what do you have your eye on for the future? What are you excited about that's gonna like take any kind of project, whether it be LED jewelry or your stuff in your job during the day, that you think is going to be like really cool and help you level up your game in the future?
So I already saw a soldering iron based
Oh
on
yeah.
supercapacitors. I think that's really smart. You just plug it in and then you can use it for a
Huh.
couple minutes. I think toothbrushes are a great fit for supercapacitors, because you charge them up and then
Mm.
you just drain them in 5 minutes, or which on you brush your teeth. But um, they're actually not a good fit for regular battery, because you don't want to drain a regular battery that fast, because it will do some damage. But
Mm. Wait, a
yeah,
soldering iron that only runs for, it sounds like a, emergency. I know that it wouldn't be disposable, but what I'm picturing in my head is like a, tear open the package, like, we need to solder something for 3 minutes, and like, I don't know, what's the benefit of like a soldering iron supercapacitor?
and no, I think I put in. I'm not sure how it works, but I think you put it in a holder and it will charge it, and then you take it out and then you solder again.
Ah,
So it's kind of wireless, yeah,
really interesting.
yeah.
Oh man,
And when
very
I saw
cool.
pictures, because someone posted on YouTube, they took it apart and it's exactly the same capacitors I'm using. So like, that's cool. So there is technology out there. I'm just looking for smaller capacitors, because the one I'm using now, that purple one, and the Amarazzi pendant and earrings,
Uh-huh.
it's a little bit too big. It has enough capacity to keep the pendant running for 30 hours. I don't think it's required for a rave. I think 10 is probably plenty.
Okay,
So
I see they're marketing it as a cordless soldering iron. That makes sense to me. Also, the part about putting it in each time, but like, yeah, I can totally see why this is, because I absolutely always like knock my soldering iron off my desk,
yeah,
by
yeah.
like whacking it with my hip or whatever. It's not great, but yeah. Oh,
But I
well,
hope, yeah, in the future we get cars probably, and anything that.
oh, especially, there's always those um ideas about like charging roads and stuff, and of course you could do the same thing with like trains and whatever. But like, yeah,
Mhm.
are there like
Especially for a
weight?
short time, like a hybrid.
Mm.
That hit the brakes, you charge the supercapacitor, and it discharges when you accelerate again.
Yeah.
It's a perfect fit for that, because you can recharge them so many cycles.
Wow. I feel like we've just gotten to the point where we get to kind of freestyle, and I wish I could hang out and do this all day. Unfortunately, I cannot. And thank you, everyone, for joining us, and thank you for taking the time to chat with
Yeah,
us. I
thank you for
really hope we
having
get to
me, and
consider.
yeah, we'll talk again
Yeah,
soon. Yeah.
we gotta nerd out. It's gonna be great. Okay, are you gonna make your fair this year?
Yes,
Bay Area,
yes, I will be there. Maker's Fair
October.
and the Oakland Light Festival at the same time. Uh,
Awesome.
I think I can do it, because there's an hour, 1 hour difference between the two. So I'm trying to manage that.
Might need
Uh,
to sleep for a week afterwards, but
oh yeah,
okay, awesome.
but I
Thanks
will be
again
at
for
both.
joining us.
Yeah.
All right,
Okay.
I'll
Thank
catch you
you.
around. See you,
Okay.
everybody.
Bye.